and welcome to another episode of Lunch and Learn with Vince. I'm Vince Marino, your host, and I'm here with a friend, Gene Vogel with EASA, who is a variable speed drive expert in the pump world. Is that a fair assumption, Gene? Or
Well, I have some expertise, let's say.
there you go. So tell me the difference between variable speed drive and variable frequency drive, and what are the purposes of having these on your pumps, Gene?
Sure. Well, the object of is to run the pump at varying speeds so you can better adapt the pump at its best efficiency point to the particular application. That's the objective, so that you can control the speed of the pump and get it operating in its most efficient operation. In order to do that, since a pump is a rotating device, you need some sort of variable speed drive, some way of varying the speed. And there's numerous different ways of doing it. I think everybody could just easily imagine, if I put a diesel engine on the pump, I can change the speed of the diesel engine just like pushing on the accelerator. And that would work. That's not a good solution for many applications. It is for some. If my pump's out in the middle of the field running an irrigation system, that's perfect. But if it's in a plant, I don't want to have a diesel engine to maintain. That's just not the way that we do it. So a diesel engine is a variable speed drive. There are a number of types of variable speed drives. DC motors are variable speed drives. There are clutches that you can hook up to a constant speed electric motor, and an electric motor drives a big drum, and there's a driven half of this mechanical device that has a magnetic connection to it, so you can vary the speed of the output even though the motor is running constant. It's called a clutch, eddy current clutch. That's a variable speed drive. The most common best known method of varying the speed of a drive is to use a standard induction motor, which has a pretty much a fixed speed that it runs at. It varies a little bit with load, but if you vary the frequency that of electricity, the AC electricity you put into that motor, you can run at almost any speed you want to. That's called a variable frequency drive. So a variable frequency drive is an electronic drive component that you hook up to an induction motor and allow it to run at various different speeds. It is one of several variable speed drives. So a VFD is one type of variable speed drive, but there's lots of variable speed drives out there, different types.
Well, let's talk about VFD for a second. Can you tell me some of the common applications where one would see a VFD?
Well, we're talking about pumps, and certainly centrifugal pumps is one of the most popular ones. And you do that for energy efficiency reasons, but they're used in many other applications. How about a conveyor? I just need to change the speed of the conveyor depending on what my operation is. Great for variable speed drives. Or variable frequency drives, either one. And another, just as with pumps, is with fans. Lots of operations need variable amount of air. How much air do you want to run through your HVAC system? So you can change the speed of the fan. You can change the amount of air that you move, just an air pump. That's all a fan is. So conveyors, fans, pumps are really simple applications to visualize where variable speed would be a big advantage.
So, for example, in a previous conversation, we talked about vertical turbine pumps to lift water.
Right.
And so let's drill down a little bit about how a VFD or VSD would apply in a vertical turbine pump scenario, and what are the pitfalls of having a VFD or in that particular application.
Sure. The vertical pumps tend to be mounted and either extend down or extend up, but you've got this long leg of a pump down there or up here that can wobble back and forth. If you gave it if you just bumped it, it would sit there and it would, have some natural frequency that it liked to shake at. And that presents a problem when you put a variable speed drive of any type on a vertical pump. They're the most susceptible to high vibration at particular frequencies. We call that resonance. And it's just as we spoke about before, it's like your wash machine on the spin cycle. As it speeds up, it hits that one speed and it starts to shake pretty bad. If it goes on by it, that's fine. It smooths out. But if that one speed, when it slows back down, it goes back through it again. You don't want to operate a pump right at that natural frequency. It's what they call resonance, and it causes severe vibration and causes all kinds of mechanical problems with the machine. So that's a problem with variable speed drives of any type, certainly a variable frequency drive, on a vertical turbine pump or any other type of vertical machine, but especially on vertical turbine pumps.
Interesting. Can you tell me a little bit more about problems versus the benefits of a variable frequency drive? What are some of the pluses and minuses?
Well, the pluses are that it works with a standard induction motor, which is a commodity item and readily available, and you're going to get the most power for the least amount of cost. If you look at other variable speed devices, and I mentioned internal combustion engines, diesel engines, DC motors, and clutches, those are expensive, more expensive than an induction motor. So a variable frequency drive is an electronic device that you can put in between your power supply and a standard induction motor and change the speed of that motor to just about anything that you would want. So that's its big advantage. It's adaptable to the vast majority of electric motors that are out there driving pumps. The disadvantages, the primary one specifically with variable frequency drives applied to an induction motor is that the high frequencies used, the way they generate the variable frequency, creates the potential for a voltage differential between the stationary part of the motor and the rotating part of the motor, between the stator and the rotor. And the only thing in between the two is the bearing. So if you create a voltage potential between two things, you're going to get current flowing, and that's going to cause current to flow through the bearings. Current flowing through bearings is bad. Anytime you get a voltage potential, you have the potential for arcing, and arcing will create damage inside the bearing. The rolling elements in bearings run on a very thin film of lubricant. And when you run electricity through that, you get a little bitty tiny spark. And we're not talking big sparks. We're just talking microscopic amount, but it can be happening millions of times in a minute. And that constant imposition of those tiny sparks as electricity discharges between the stator and the rotor through the bearing does what we call electric discharge machining. The abbreviation is EDM. EDM. Could I show you a picture of it?
Yeah, please do. Please.
Let me see. I've got one here. This is a subject that comes up. So let me share my screen here for a second. And
EDM.
Let me know when you can see that.
Oh, I'm seeing it. Electric discharge machining, common with VFDs. And I'm looking at some etching, it looks like.
Right. And if I can get my pointer going here. Let me get my, there we go. And these little lines, and they're very easy to identify. It almost has a design to it, a pattern to it. And I can't explain why that happens, but it does. When you see this type of damage to the inside of a race of a bearing, it could be inner or outer race. That's almost always caused by shaft currents going from the stationary part of the electric motor through to the rotating part of the electric motor. So you'll hear your bearings start to squeal, I mean, not squeal, but it'll have a noise to it. Your bearing will get noisy, and if you're lucky enough to recognize that that's a problem and pull it out before it fails, you'll pull the bearing apart and see this. If you're not, and you let it keep running, maybe it's in a noisy environment and nobody's bothering to check the vibration on it. Eventually, the balls rolling over this, or rollers running over this, are going to pull metal and damage the bearing, and the bearing will fail catastrophically. It'll ruin the bearing.
So Gene, the whole purpose of using VFDs or VSDs are to reduce costs and sustain the equipment, right? Sustainability. How does one avoid this kind of an outcome?
Well, there's a couple of things you can do to mitigate the discharge of electricity through the bearing of an induction motor. You can isolate the bearings electrically. In other words, put a non-conductive material on the outer race and inner race of the bearing where it touches the shaft and where it touches the housing, so electricity can't get through it. There are also bearings that have ceramic rolling elements. And the ceramic, of course, is an excellent electrical insulator, and that will, reduce the possibility of electric going through the bearing. A whole different approach would be to say, well, we got the electrical potential here, it's going to flow one way or another anyway. Let's give it an easy path, and we can mount a brush on the stationary element of the machine, of the motor, and have it touching the shaft so the electricity flows through the brush instead of through the bearings. Those are the two primary ways of approaching mitigation for shaft currents through electric motors.
So Gene, if I could go back a little bit, you've been around pumps a majority of your life, I would imagine, right? I think you started as a young man getting involved in pump and pump repair. What is your preference to mitigate these kind of electrical damage? What do you choose?
I'd say do both. Put insulated bearings in the motor and put a shaft brush on it. As a retrofit, of course, that's an expense. For a new motor, you just buy the motor that way.
With a brush?
Well, not only with the brush, but the brushes, yeah, they'll put brushes in them for you. And but the bearing, the insulated bearings, the insulated bearings are available as an option for any electric motor.
Right. Okay.
Most electric motors.
Right. I see. You and I talked a little bit before this conversation, and I understand that, like I said, as a young man, you got involved in the pump repair or pump business. Maybe you can tell us a little bit about history of where you came from and how you got connected up with EASA.
Yeah, well, I started working at a service center repairing machinery. I started there in high school. They came in and swept floors, and I got out of high school, and they put me on a bench, bought some tools, started repairing machinery, and I worked my way through college doing that. Pretty much raised a family doing that too. And in any event, we repaired all types of machines. And I was basically a mechanic, and I repaired, not basically, I was a mechanic, still am a mechanic, but we were, take them apart, do whatever machine work needs to be done to them. If they're an electrical device, do whatever electrical device. You had an electrical department took care of that. I was in the mechanical department. So I'm familiar with machine work. I'm been working as a machinist. I got involved in the balancing at that time, is what we called it, the dynamically balancing so it didn't vibrate. That was a big part of what I became involved in. And if you had a machine, you couldn't balance it or get the vibration out by balancing it, you did what called vibration analysis to figure out why. So that's an area of expertise that I specialized in later on.
Nice. So the variable speed and variable frequency drive opportunity or it evolved over time. It was something that wasn't in factories to begin with, and over time the need evolved, I think, and once it proved that there was some efficiencies and sustainability of the equipment and reduced costs, it became more of a thing to look for. That's where that's an area that you kind of delved into and are extremely knowledgeable in now. I'm assuming that you've seen a number of customers and clients that have had issues where you come in and you make suggestions and make changes.
Well, yeah, our members, EASA members are independent service facilities. And the vast majority of them have some sort of field service capability where they can go into manufacturers and whoever, the customers' plants, and help them with problems and provide solutions for them specific to their particular needs, and especially on an individual application basis. These are the folks who figure out, what needs to be done and get it done. One of the solutions that they offer will be the conversion of an existing application from fixed speed to variable speed. And usually the most common way of doing that is with a variable frequency drive. The development of variable frequency drives happen apart from their application for pumps. And what made it possible was the development of the SCR, silicone controlled rectifier. Okay, that's at the heart of a variable frequency drive. All of them work pretty much the same way. Until that electronic device was created, you couldn't have an effective variable frequency drive that was economical. So that was the invention that started it. I believe that was probably in the late 60s and 1970s where that became, a reality in industry. SCRs became a reality, and variable frequency drives. So it's developed, it's grown since then. Pumps are one of the many applications that can benefit from it.
And again, pumps is your area of expertise as it relates.
One of my areas of expertise, correct.
So tell me a little bit more about just day to day. I mean, what do people reach out to you for consultation?
Yeah, I'm available to our members. So EASA is a member-supported organization. We have over 1,800 members around the world. They are, for the most part, independent repair facilities. Some of them are associated with the repair facility associated with a larger corporation, but most of them are independent repair facilities. So my expertise is available to them, and they're the folks that I'm talking with. So they'll have an issue somewhere in the field or somewhere in their service center, and they call me up and I help them to the extent that I'm able.
Awesome. And this is where if you're asking for some diagnostic type questions, like what is your rate of flow and so forth, they would be able to help you and possibly even over the phone come up with some kind of a resolution or solution.
Right, and I usually get involved when there is a problem, so it's usually problem solving. There are occasions where I work with the members on some new installation or retrofit to help them with the technical side of figuring out what speed it needs to run. And of course, if they encounter vibration issues because of resonance or anything else, then I get involved in that as well. So I'm working with members. and providing them with the additional technical expertise that they might need to solve some problem at a customer's facility.
Well, I can imagine no 2 days are alike for you, and it's probably new things every day, I would imagine.
That's one of the things that keeps me going, is that every day there's something, new or different that comes up. Yeah, it's definitely not tedious.
Well, can you name or share a story where one of the members called you and presented you with this is the challenge and how you offered the solution? I mean, can you give me an example, without naming names?
Oh, yeah, sure. And not directly associated with the variable speed drive application, but with pumps.
Yeah.
Member pump had been repaired by a pump company. When they put the two back together, the motor pulled. So it's not an uncommon thing. They're trying to solve this problem, and I asked the question. It says, what's the head and the flow rate of the pump? Because you have to look at the pump curve. If it's pulling high current, how much current should it be pulling? And he gave me the numbers. They went back to their customer, got the numbers, and I said, well, I'm looking at the pump curve, and that pump can't do this. What you're telling me the pump is pumping in terms of head and flow, that pump is not capable of doing it. Would be like if you told me you had a little bitty Ford Escort and it was going 200 miles an hour. It can't do it. It's impossible. And I said, well, that's what it's doing. They've got it measured. I said, well, one of two things: either this is not the right pump curve, or that's not the right pump, because they're not matching up. Make long story short, the people who overhauled the pump replaced an impeller, and the manufacturer sent them the wrong impeller. They sent an impeller with 7 vanes instead of 6 vanes. And it changed. So it was not the pump that they thought that they had. And there was no way that motor was going to work in that application.
Interesting.
But I knew as soon as he gave me the numbers that something, the problem is not the motor. We have a Murphy's Law. You've heard of Murphy's Law. Okay, we have Murphy's Law for warranties on pumps and motors. If you repaired the motor and the pump isn't working, the problem is the motor. But if you repaired the pump and the electric motor is pulling high current, the problem is the pump. That's just the way it always works out.
Yeah. Wow.
So in this case, the problem was the pump that was causing the motor to be overloaded.
Well, is there anything else we can drill into? I mean, we talked about variable speed drives it's kind of a generic term, could be just about anything from a diesel powered motor with an accelerator, right?
Right.
We've talked about that. We've covered VFDs, which you have to be careful of VFDs because you have to be careful of the current where it can cause the bearing damage and other
Shaft currents.
Yeah. And the way as it relates to motors, I think the vertical turbine example that we talked about earlier and the wastewater world, that is something. If I could kind of drill down a little bit on that, if you got a if you have a vertical turbine motor, and we talked about how that shaft can kind of move around a little bit inside of the case, if you will, inside the pipe. There's I call it a tuning fork, but there's a resonance, a vibration, a frequency that long shaft vertical turbine pump has. Just everything has a vibration. And I think you mentioned that you can pinpoint the frequency of that shaft, if you will, and then guide the VFD to stay away from that somehow, except during,
Right, right. It's actually the entire pump assembly. It's a column, not just the shaft, but there's a column that goes down and the liquid comes back up to the column. So the big long tube, if you will, that sticks down into the sump and sucks the water up. And since it's reaching down so far, it doesn't have a lot of stiffness. And if you just took and gave it a wallop, it would sit there and go, back and forth at some frequency, just like a tuning fork. You don't want the pump to operate at the same speed, rotating speed that pump likes to vibrate at. That's called resonance, and it causes severe vibration. The VFD devices have the ability to program lockout speeds. Of course, if it's starting from 0 and going up, it's got to go through there, but it won't stop and hold it at the speed where the resonance occurs. If you go through it pretty quickly, it won't be a problem. But if you let it sit there, the vibration will build up and become very, very severe. So the VFDs have got lockout frequencies, and who commissions that machine when they set it up, or whenever it's installed and hooked up, someone's got to properly set those frequencies so that you stay away from those natural frequencies and resonance.
interesting.
The problem is people don't know that, and they think a VFD is just a simple solution. Just put it on there and I can change the speed any way I want. And they may go out there manually and change the speed and get it at a speed where it's going to vibrate severely, and it destroy the machine. So it's one of the gotchas with retrofitting a fixed speed pump with a variable speed device of any type, is you've got to stay away from natural frequencies.
Yeah, and I would imagine that if it's not a world that you live in on a day-to-day, that's an area that you would need some expertise.
That's correct. That's a combination of a knowledge of pumps and pumping equipment and vibration analysis. The nexus of those two is rather unique bit of knowledge, if you will, that but it doesn't have to be real technically difficult. If you can just run the machine up through its range and see where the frequencies are, where it tends to vibrate, and stay away from those and program your VFD to avoid it, that's basically what you're doing. Where it gets technically demanding is where you try and predict where that's going to happen before you do it.
Yeah, I would imagine that would be more of a challenge than actually physically saying this is the area I want to stay away from due to the evidence. Right. I would imagine that if you're staying in the wrong frequency too long, you're right, it probably is catastrophic damage to that equipment.
It can and does happen, yeah.
Can you tell me a scenario that you're aware of where that did happen, where that it was just allowed to stay in that residence in a bad place for such a long period of time? How did that happen, and how was that allowed to continue to where it caused damage? In other words, was it a remote location? Out in the field?
Yeah, let me just clarify. Since I'm working with our members, they're the ones who will see it, and I'll only see it after the fact. I'm not involved in it, intimately until there is a problem. I would have to go way back to when I was doing field service with the service center to find instances of where we had resonant problems that tore up a machine pretty bad. And that's been so long ago, golly. Yeah. I've seen them, I've experienced them, but right now it's our members who deal with the end user on that.
I gotcha.
It would be difficult for me to really give you a good, war story here.
Well, and thank God, because you don't want that to happen. It's good that they have you as a resource, though, to call upon these members.
Well, that's one of the things that makes the job so enjoyable is, that they call up with a problem and you're able to help them. I mean, it's just, that's reassuring everybody likes to do good things for folks when they're having trouble. And that's my job, is to help folks when they're having trouble.
Yeah, I think that's awesome. It seems like it was like a kind of a lifelong progression where you got involved in making the repairs and kind of gradually moved into this. And
I tell the story of it that when I was very young and probably 7, 8 years old, my dad took me with him to the junkyard to get a part for the car. We didn't buy new stuff; everything was used and repaired. And all these motors sitting around, and I said, "Dad, I want a motor." And what are you gonna do with it? I'm gonna work on it. And so he got the guy at the junkyard to give me a generator when cars still had generators instead of alternators. That's my favorite toy. He gave me some tools, and I'd take it apart, pull the brushes out of it, take the little pieces out, and put it back together again. So I guess it was predestined I was going to end up in this industry.
yeah, so
just by chance in high school, they needed somebody to come in and sweep floors after school, and I was looking for a job. So,
yeah, it's a great story, Jane. So how would I'm going to go back to a member, for example, get in touch with you? They would do it via EASA, via the website.
Our members, yes, they can call us up on the phone. They can send us an email. They can send us a fax. We still have members who fax information in. It works. So any means of communication, we're available to them, right? Yeah. And if some end user needed that information, you can go to EASA.com and just find your local EASA service center and give them a phone call, and they'll be glad to help you. And if there's something that I can get involved in that, then we'll do that through our member.
Wow. So EASA is available. Like I said, members would then reach out to you, or if an end user had a problem, they would get in touch with one of the regional members. And if it was a problem that your area of expertise would be required, the member would then steer towards you and get the help with the resolution.
That's correct. And everything that we've talked about today, the majority of our members know that. They've been to my training classes. So that's my job, is to keep them informed of this. So this information is available to them. And the chances are, if someone at large contacts an EASA member with this issue, they're going to get the issue solved. I would not come and get involved unless there was some sort of a problem that the member needed help with.
Absolutely.
Our members are very knowledgeable and have some tremendous resources available to them, not only through EASA, but they're great organizations. These are independent folks, independent business people, whose job it is to find how to solve problems for their customers.
Yeah, EASA is probably one of my favorite. Well, it is my favorite show. They have all the really cool equipment, so it's always fun to go to that. And we're going to have one this June coming up in Maryland, so that should be fun. I assume you're going to be there.
I will be there, looking forward to it. It's where our communication is always via phone and email, and I mentioned fax, but whatever, throughout the year. And that's the occasion where we get to go in and shake the hands and sit down and have one-on-one conversations with the folks. Yeah, it's a good time for everybody.
Beautiful. Well, Gene, do you have anything else to add? If not, I'll wrap things up. But I can't thank you enough for taking a little time to share a little bit about you, yourself, and variable speed drive and variable frequency drives.
Right.
Got anything else to add?
Thank you so much. And EASA is, I'm glad to work with you anytime that you have questions. If there's other topics that come up that you would like to have a discussion on, give us a call. We'll take care of it.
Well, thanks. I hope we can drill down on a couple of other topics on future lunch and learns. I would like to hear more a little bit about that electronic damage of the bearings and kind of drill down in that direction. I am curious about that a little bit more, but for another show.
Sure.
But for now, Gene, I can't thank you enough for joining me on Lunch and Learn with Vince. Folks, if you like this video, please like and share with your friends, and please tune in for future Lunch and Learn shows here on Empowering Folks.